Sıradaki konuşmacımız Micron'un EMEA Kurumsal İş Geliştirme Direktörü Esther Spanjer. Micron EMEA Kurumsal İş Geliştirme Direktörü olan Esther, bellek ve flash endüstrisindeki 25 yılı aşkın tecrübesiyle bulut sunucu ortamlarındaki bellek ve depolama çözümlerine yönelik gereksinimler konusunda değerli bilgiler edinmiştir. Uluslararası yayınlarda ve konferans tutanaklarında 30'dan fazla makale yazmıştır ve ICS, Flash Memory Summit, Storage Networking World ve Storage Developers Conference dahil olmak üzere çok sayıda sektör etkinliğinde konuşma yapmıştır. Amsterdam Teknik Üniversitesi'nden elektronik mühendisliği alanında master derecesi ve Presidio Graduate School'dan MBA derecesine sahiptir. Şimdi konuşmalarını yapmak üzere Esther Spanjer'i sahneye davet ediyorum.
Good afternoon, everybody. Can you all hear me okay? Yes. So I'm standing in between you and lunch, so that's a hard one to do. But I hope it will be worth your time. So for those of you that are here today, my name is Esther Spanjer. I work for a company called Micron. And Micron is a very large semiconductor company. We make memory and storage products. We are headquartered in the United States. We have over 44,000 people working for the company worldwide. Large company. I am responsible for business development in specifically for enterprise products, so products that go into the data center with a big focus on Europe, but I also do some projects worldwide. Now, if you why are we here today? Obviously, when you're looking at building infrastructure for your data center, you also need to have a big part of that infrastructure is going to be memory and storage that are sitting inside your server or inside of your storage array. And so what I want to talk to you today about is some of the trends that we're seeing in the hardware, in the data center when it comes to artificial intelligence, because that is, of course, the big driver that we're going to see will really impact the hardware that we're going to have in our data centers, and what does it mean from a memory and storage perspective. How is this all fitting together? So Micron overall makes memory and storage for a wide variety of markets, products. We make memory that goes into our watches, that go into our cell phones, that go into our cars, but of course also go into the data center and into a server. And so specifically what I will talk today about is those products that are going to go into a server and in a data center. We're not here to talk about cell phones at a day like this. So when we're looking at Micron overall, we are really a very large global company. We have manufacturing all over the world. We have manufacturing, of course, in the Far East, but also in the United States. We're building actually 2 large new manufacturing sites in the United States, quite unusual for a semiconductor company. Typically all of that is done in China, but with the changing geopolitical balance in the world, our company is also building new facilities in the United States. Now, what I'm really here to talk about is artificial intelligence and how do we prepare our data centers for this massive amount of data that is going to come with artificial intelligence. It's kind of like a nice buzzword, right? Everybody talks about artificial intelligence and it's going to change our world. But I think what a lot of people tend to forget is that in order to build any kind of artificial intelligence model, we need to crunch a lot of data. There's going to be a lot of data that the algorithms need to go through to try to create something that is going to be an AI model. And when you're dealing with a lot of data, you're going to have to deal with a lot of memory and with a lot of storage, because you need to put that data somewhere, and then once you start computing with that data, you will need a lot of memory to feed into your CPUs and GPUs. So data really is at the heart of every AI infrastructure. And so how do you deal with that data? What is the best way and the fastest way to create these AI models and to implement them? So when we're looking at, okay, all right, I forgot that I sent a PDF. So when we're looking at artificial intelligence and we're looking at the clusters that we're going to build in our data center, there's kind of two big segments of the hardware that we can look at. First of all, we're going to look at the hardware that we need to train the AI model. When we're trying to build an AI model, the first thing we need to do is actually teach the AI model what it is that we want this model to predict. So when we're taking, let me take an example of what this would work like. So for example, I have a hospital that has a doctor working in the hospital that is going to use AI to help him predict the type of cancer that his patient has. So he has a patient, he has, let's say, a medical image of the lungs of that patient, and he will use that the AI model that he has will help him determine what's the cancer type or how bad the cancer is of that medical image from the doctor. Now, in order for the AI model to even say that, the AI model needs to be trained. It needs to have looked at hundreds of thousands of medical images before so that it can actually predict, right, what the image of that particular patient is looking like. So we first need to start with scanning and feeding into the AI model hundreds of thousands of medical images so that we can build an algorithm, we can build an AI model. So that feeding into the AI model is the training stage, right? We first need to build that model. So we need to train the model, what it means, what is, what kind of information are they going to find in that medical image. So this requires hardware that is going to be capable of crunching a lot of data very, very fast, because you're going to have to, feed tons and tons of data into that model so you can teach that model. So a lot of compute capabilities, a lot of data storage, and a lot of memory. Now, once you've created the model, we go to the actual implementation in the hospital, what we call inference. So in this case, the model already exists. It's going to sit on some kind of server, and then the doctor is going to feed that one image of his patient into that server, and then lets the AI model help him predict what's happening with his patient. At that point, the amount of hardware that we need in order to help that doctor get that answer is going to be much more moderate. There's going to be a lot less compute requirements, there's going to be a lot less data requirements, and a lot less storage requirements. So the two pieces of hardware that we're going to separate are much more compute-intensive hardware for the training piece of my AI implementation, and then much more, if you will, general purpose servers that we've always been using for the inference piece. So let me kind of look at that, show you that with, of course, with the storage and memory products that we are selling, because at the end of the day, I would love you to buy some of that. So let's look at the first of all, these big servers that we need for training. So when we're going to crunch a lot of data, when we're going to do a lot of compute capability, I probably will be looking at one of these big fat servers that will have a lot of GPUs inside there. because I need to do a lot of computational activities in order to create that AI model. When you have a lot of compute requirements, a lot of GPUs, it means that the storage that sits in front of that GPU needs to be very fast, because otherwise my GPUs is going to sit there and do, and not basically work in the most optimal way. So the storage that you want to have sit as a cache in front of your GPUs need to be the fastest storage device that you can find. In this case, it can be a Micron product, it can be from any of our competitors, but the highest or the best kind of storage that you can find in the market today will be an NVMe SSD with the highest capacity, up to 30 terabyte if you're required to do so. And why would you need the highest and the best performance and the best capacity in this case? Because of your GPUs. Your GPUs are the most expensive thing in your hardware infrastructure. I met with a cloud provider a few weeks ago back in the Netherlands that is doing a lot of GPU cloud hosting. They told me that 80% of all of their hardware money is going to the GPU. 80%. 15% goes to networking, and 5% goes to memory and storage. And so optimizing the GPUs that you have in your infrastructure and making sure that they're going to be working all the time is going to be very important, which means that you need to have very fast storage and memory that sit together with that GPU in these big servers. Now, when we're looking at the inference piece, so remember that's the part that we were, looking at in our hospital. The server can probably be much more moderate, because at this point we've already built the AI model. We just have to help the doctor with a prediction for that one patient that he is looking at. So it will probably be much more a general purpose server, very similar to what we've been using kind of historically. So in that case, we probably want to find a storage device that is fast enough, but it's not, the absolute Ferrari of the storage devices. It needs to be the right balance between cost, performance, and capacity within that server. In this case, you want to go for what we call a mainstream NVMe, kind of your average, middle of the path type of SSD. And then finally, we have something that we theoretically are starting to use in external storage arrays. So when we're building these AI models and we need to feed these hundreds of thousands of images into our servers, those hundreds of thousands of images first need to sit on an external storage array. Historically, that's always been done on hard disk drives, because that's the cheapest way that we can store our data. The challenge that we see with storing it on hard disk drive is, again, interestingly enough, the GPU. So when I transfer those hundreds of thousands of images from my external storage array into my server that has all these GPUs, I need to make sure that the GPUs in that big server are not going to be sitting there waiting for the storage for the data to arrive. So I need to be able to transfer that data as fast as I can from my external storage array into my server. When you use hard disk drives on the external storage array, you have a bottleneck in terms of performance, because hard disk drives are slower. If you change that with a bunch of much faster SSDs, you can feed that data much quicker into your GPUs. So then, of course, everybody will say, well, but, it's going to be much more expensive. Okay, we gained performance, but we also spend a lot more money. And while that is true for the actual storage appliance, right? If you build a storage appliance with hard disk drives, or if you build it with SSDs, of course the storage appliance is going to be more costly. However, did you look at the cost of your GPUs? If you have, 4, 5, 6 GPUs sitting in your server, remember that was 80% of my cost, and it's sitting there idle, not doing anything because it's not getting the data from my external storage array, then you're not optimizing the overall system cost. And so when you replace an external storage array with a much faster storage array, even though it's more expensive, your overall system cost will potentially be better. For example, we did a test. We transferred 100 terabyte of data from the external storage array into my GPU server. One time we used hard disk drives, the second time we used SSDs, and the improvement was 4 days. Okay, so not minutes, not hours, not seconds, days. So you can imagine that if you have these big servers that run all these GPUs, and these GPUs are sitting there for 4 days doing nothing, that is not the best usage of my GPU hardware. And so in certain cases, it is absolutely interesting to start replacing hard disk drives with SSDs. All right, so when we're looking at the overall storage type of SSDs that you can find in a server, we really are starting to segment it into, okay, I want an SSD for these big fat GPU intensive servers. I want an SSD that is more for my general purpose, what we call inference server, and I want an SSD for possibly my external storage array. Now, I'm not going to go through all the names of the models, but I hope you understand that there is, quite a lot of segmentation and optimization depending on what the purpose is of the workload that you are going to run in your data center. So, looking on it from the memory side, when we're looking at artificial intelligence, of course also on the memory side, we always want bigger, faster, and better, right? That's typically the story in IT. So we want better performance and we want more capacity, because at the end of the day, that's what we need in an AI infrastructure. So when we look at it from a memory perspective, we're going to get more and more performance in our servers by putting CPUs in our servers that have more and more cores, right? We're seeing this trend. We're transitioning, from, once upon a time we only had, single-digit amount of cores in our CPU. We're now transitioning to over 100 cores and beyond in the CPUs that we're seeing in our servers. And when you have more cores in your CPU, you're gonna need more memory. You're gonna need to have more bandwidth, memory bandwidth, to feed those cores, because otherwise there is no point to have more cores. And what we're seeing in the industry is that both Intel and AMD are coming out with platforms this year and beyond that basically are increasing the speed of the memory that sits behind those cores in order to make sure that the cores, the increased amount of cores, are getting more and more bandwidth. So we're transitioning the memory speed. At the moment, we're at 4,800 mega transfers per second. We're transitioning later this year to 5,600, and by the beginning of next year to 6,400 mega transfers per second. There is a roadmap to already 8,800 and beyond. So the push always will be for more and more memory speed as well as more and more memory capacity. So from a speed perspective, we're absolutely seeing this transition happening quite quickly. One interesting side effect of going for more and more cores is that that means we also have to buy more and more capacity. When we have more cores, we need to have more memory sitting behind each of these cores. And in many cases, the customers are buying the memory because they need the performance, but they didn't necessarily need the capacity. And when you're buying DRAM, you typically buy it in the regular binary chunks, 16 gigabyte, 32 gigabyte, 64, etc. And so customers ended up buying a lot of capacity that they didn't necessarily need. They only needed to buy that module for the performance. So you end up with what we call stranded capacity. You're basically paying for something that you're not really using. And so what the industry came out with is these non-binary capacity points. So these in-between capacity point, 24 gigabyte, 48 gigabyte, 96 gigabyte. So now a customer can, when they need more speed, they can add more memory, but they can much more fine-tune it. They can now go from 16 gigabyte, instead of jumping straight away to 32, they can now jump to 24. Or instead of jumping straight away to 64, they can also use 48 gigabyte. So it allows for a more granular optimization of all of the hardware and finding the right balance between, again, cost, performance, and capacity. And so that is this new kind of funky thing that we're seeing in the memory space, that we have these non-binary capacity points. And then the one thing that in the data centers everybody is asking for, especially when it comes to the AI world, is higher and higher capacities, right? We want more and more memory in our systems. And so 128 gigabytes today is going to be the highest capacity that you will find in a module that you can stick into the server. Today, Micron happens to have, for those of you that understand the technology, we happen to have a better product than all of our competitors at the moment. It takes another 6 months before our competitors obviously will be there. At the moment, we have an advantage because of the way we manufacture the product, and because of that, we currently have basically a better cost, a better product that uses lower power, has better performance, and also lower cost than our competition. Again, if you're buying these kind of things, understand that today at the market, if you want to buy 128 gigabyte DRAM, just one module will cost you somewhere between $1,500 to $2,000. Okay, and an AI server can have multiple of these things inside. So this the particular product from Micron will probably be about $1,200 at the moment. So you can imagine that that is a very big cost saving at the moment. And then really what we're looking at from, in the overall data center space, AI is going to drive huge demand for more performance, for more capacity. And so what we're seeing in the servers that are being built for these data centers is that they're going to have, up to 8 times the amount of memory and potentially up to 3 times the amount of storage that you would see compared to a regular standard server. So huge uptick in, the requirements in the hardware that, is going to drive the AI infrastructure in the data center. That is everything. Oh, don't know what happened here. Everything I wanted to share with you today. We are fairly new to the Turkish market in terms of our presence here. We're not a new company, but we're fairly new to the Turkish market. I am not located in Turkey, but my colleague Yunus is. So we have a booth downstairs if you're interested in come to talk to us a bit more about anything related to memory and storage. We're here the whole day. I also put my email on there, espanjer@micron.com. I'm probably the only blonde one here, so I'm not so difficult to find. And with that, I wish you a great lunch and thank you for listening.